Okay guys, this is the continuation of the topic from where we left off during the live class. So lastly I gave a circuit problem for you guys, and I wanted to you guys to draw the equivalent circuit of that coil with the cell. I hope you remember what was the question, guys. You had a coil like this, and I named this one as A, D, C and B, and this coil was moving with a velocity V and was in the presence of a magnetic field into, right? And I asked you to draw this circuit in the form of cells. That is, you have to represent this entire thing in the form of cell. So I'm going to take it in a fast pace, guys, because this much portion I have already took. Let's first consider just this rod AD. So this rod AD, right, is in a magnetic field like this, right? So the entire coil is moving with a velocity V, means then the AD rod is also moving with velocity V, and in such a way that it is perpendicular to the field, right? The entire length is perpendicular to the V, right? So that means I'm not going to give the direction. This is V, B, then take your palm to all the fingers has to be downwards, so that the thumb gives the direction of higher potential, right? So D becomes higher potential and A becomes lower potential. I have taken during the class how it became higher potential, lower potential, etc. I have taken. So D is at higher potential and A is at lower potential, means L vector is in this direction from lower potential to higher potential, right? So that means this entire thing, right, AD can be replaced by a cell that I have told you guys. So what will be the replacing? So in place of AD I will draw it like this, right, the cell like this. And what will be the EMF there, guys? EMF, what is the equation? I hope you remember V cross B into L. What is the angle between V and B? 90 degrees. So it will be just VB. And what is V cross B's direction? It is also in this direction, right? V cross B is also in this direction. And L is also in the same direction, lower potential to higher potential. The angle is 0 degree. So V dot, so the V cross B dot L, right? So this dot product, that is sine value, sorry, cos value, cos 0, right? Because the angle between L and V cross B is parallel, right? So the angle is 0, so it will be just VBL, right? So I'm going to replace this with the cell VBL. Right. Similarly, also the CD is just like AD, right? So CD can be also replaced by the cell like this, VBL. Right. Now, what is the case of the rod section, that is DC? Right. DC, guys, when I consider this entire length, right, this is in parallel to the V, right? See this entire length, whatever higher potential, lower potential, whatsoever, this length L is in parallel with V. So I have told you any two terms, right, in this equation, any two terms are parallel to each other, then the induced EMF is 0. So DC can be just drawn as it is, and AD can also be, right? DC is just same as that of AD. So it can be, I'm going to draw the entire figure again, guys. So let's take another color. Okay, right, so I'm going to replace this. Okay, I'm rubbing it off, right, so that we can replace this entire circuit with an equivalent circuit. It will be a cell like this and another cell like this. Oh, this is VBL and this is also VBL, right? So you got an equivalent circuit with cells. Now what will be the total EMF, guys? Both same polarity, right? So the total, these two cells will be negating each other. So the EMF, total EMF will be equal to 0. The total EMF is equal to 0, the current is 0. That is what we took earlier, right? You need not draw this much section to know what is the induced current in that coil, but I wanted to make you understand. Clear? Let's do the next problem. Right, now the question is, this is a magnetic field, right? In place of a full coil I am having a half coil only. Right. Okay, let's take another color, guys. Let's give some spacing also. Right, and the coil is like this. Right, say the coil is having radius r, right, and it is moving with the velocity like this, right, and you know that the length will be equal to 2r, right, this two end. I'm going to consider these two end. Okay, let's say this end is A and this end is B. So there will be 2R. I'm not giving the direction. Pause the video and try to find out what will be VA minus VB. That is a potential difference between A and B. Let's say make it as VB minus VA. Okay, in place of VA minus VB, write it as VB minus VA. So how would you find? Pause the video and try to find it by yourself, guys. And if you don't, I will prove the answer now itself. Right. We know one thing for sure. Why? This coil is not complete, right? That means I can be damn sure, this is A and B, that what? There is induced EMF, but there is no current. So the current is equal to 0. Right. So my first section is to find induced EMF. What was the equation for induced EMF? V cross L dot, sorry, V cross B dot L. Sorry guys. So I have to first find what? V cross B. That is my first function, or what to do. I have to at least find the direction of V cross B. Again, V's direction, take your palm, turn your fingers downwards. That is the direction of B. Then you will get the direction of V cross B in this direction. That is your V cross B. Right? You got the direction. That means all the potentials, that is, this is V cross B, means which is the point which is higher potential. A is at higher potential and B is at lower potential. So in which direction the length is? It is from here to here, lower potential to higher potential, right? So this is my L vector. So L vector and V cross B are in the same direction. So the angle between V, that is this dot product, right? So that is dot, means it is sine, right? Sorry, cos. I don't know why I'm making mistake. So dot product means cos. So cos 0 becomes off, right? You do not take, right? So this V cross B, just L, right? Now what is V cross B here? V and B are 90 degree, right? So I can just write it as what? V B L, right? And what is L? I just found here 2R. So I can write VB into 2R, right? So that is the equation, or that is a value of potential between A and B. Very simple, right? And if it had been, see, this is VB minus VA, right? That is lower potential minus higher potential, right? So it will be minus value. If it had been VA minus VB, that is higher potential minus lower potential, then it is plus VB by 2 or into 2R. Right, I hope you understood. So both the values might be there in the examination. Always find when higher potential minus lower potential, it is a positive value. Lower potential minus higher potential, it is a negative value. Clear? Let's move on to the next section, guys. It is also a problem. We are doing a lot of questions because you will see a lot of questions in your textbooks. Almost all cannot be done during the video classes. Some of them you have to do by yourself. Right, now let's move on. Again, in place of semicircle, we are going to take a circle, right? It is in the magnetic field, say like this. Right, this is your magnetic field, right? Let's take some points. This is R, P, sorry, this is also P. This is S, let's say. And let's say the radius is also R, right? You are asked what is VQ minus VS, VP minus VR, and VQ minus VP. This is your question, right? It's easy, right? This is your homework, guys. I want you guys to do it and submit today itself, right? I will be posting this video for Wednesday. So on Wednesday before 5 p.m. I want you guys to give the answer for these three, right? Clear? Out of this, I think VQ minus VS and VP minus VR you can do. I don't think you can do this one. So what will I do? VQ minus Vs and Vp minus Vr. There, see, it's very easy here. VQ, that is potential between Q and S. This is just like the previous one. Vp minus Vr, just like the previous one. So the problem is this one that I will take now. I just remember this is different. That is between this point and this point. Right? So how would I do it? Right, so I'm going to draw this circle only, right? Field is inwards, you know, right? So this is our point Q and this is our point P, right? So I will consider this, that is a distance, or I can say displacement between Q and P. So that means I'm going to replace this one section as a rod, right? And which direction the velocity, so the question I didn't complete, right? This circular section is in this direction velocity. So this section will be also in the velocity v here, right? Right. Now, remember, once you have been given direction of v and you are given the direction of field, now we can find the direction of v cross b, right? So take your fingers, right, turn towards downward, right? You will get the direction of v cross b like this. You have to find, right? So I also have told you v cross b direction means this will be in higher potential, this will be in lower potential, right? So the L vector will be in this direction, right? This one all I am not going to repeat it, guys, something which has been taught to you guys. Okay, so you got some terms, right? I'm going to redraw this section. So only the rod section, this is Q, this is P, right? So this is a part of circle now. This has been, see, I'm going to take another color. This would have been the part of circle itself, right? So this is that part, okay? Right, so this will be radius R and this is also a radius R. So this will be how much? Root 2R, right? Right, so that means this length, this is root 2R, or I can say this is the value of L. This much should be registered. We found the direction of V cross B, we found the direction of L, then we have also found the value of that L. Now what is V cross B here? V cross B is VB. Why? Theta is 90 degree. Right, now we have to find what? VQ minus VP, that was a question. VQ minus VP, that is VB, right? V cross B goes off dot L, right? So that means here dot, that is VBL cos theta, that is what is the angle between V cross B and L. This is V cross B and this is your L, right? So it is easily seen, that is 45 degree, right? Very easy. This is 90 degree, this is half of it, so this angle is 45 degree. Easy, right? It's easy if you understand the logic of it, guys. So in place of this dot I am going to remove, right? This dot I am going to remove, right? And I will write VBL cos 45 degree. Right, and now it's not over, right? What is the value of L here, guys? I just wrote here root 2R. So VQ minus VP is equal to VB root 2R cos 45 degrees 1 by root 2, right? So this root 2 and root 2 goes off. The end result is what? I'm going to rough it off. I'm going to write it here again. It's just VB R, right? It's easy, take your time, it's not that tough. If it becomes tough if you make it tough, okay? Now there is a last portion from this section. After this we have to do some real problems, so let's move it. Suppose you are having field like this, right? And there is a, let's make this one as another color, guys. So this is your field, and this is a coil which is just trying to enter, into this field, right? Sits a square coil. So the length of one side is L, means all the sides will be of the same length. Common sense. Now let's say this is having a resistance RO. Let's say this field entire length is D. Right, all the barometer is given, and that means that this coil is just entering. Okay. Now I hope you understood the figure. And the question is, draw the graph for flux as well as current with respect to time. Right. So that means at t is equal to 0, that is initially t is equal to 0, the coil has just entered. Okay. So you have to draw the graph for flux and current with respect to time. So how would you draw it? If it is taking a lot of time, in the next video we'll do the rail problem. Okay. Let's see. Right. So I hope you understood the figure. Now we are starting, guys. Right. So that means let at time t. Right, it has entered. Right, suppose I'm just drawing the fields portion, guys. So this coil has just entered. Right, so this much portion it is inside the field. How much portion, how much will be this distance during t time interval? Say this is a coil was moving with a velocity v. I didn't complete, again I am missing out the question. Suppose this coil was moving with a constant velocity of v. Right, it's trying to enter. So after time interval t, how much distance would have the coil entered inside the field? Distance is equal to velocity into time, right? So in t time, this much distance would have traveled, right? So this much distance, this is vt, right? So distance of the coil which is inside the field during this time interval t is vt. Clear? This much is very easy to understand. Right. So that means what is flux? Phi is equal to B dot A. Right. So B I can write like this. Now this much coil has entered, right? So this is the VT length. What is the length here? This is L. Right. So area of the portion which is now inside the field is VT into L. Right. Length into breadth. So this is your flux now. Right, so what will be EMF? That is d phi by O dt, right? So d phi by dt means I have to differentiate this term. So if I differentiate B, V and L are constant, then there is only t term. So when I differentiate, I will get just B, V, L, right? This is my EMF. So what is current? Current is EMF by what? Resistance. So this is BVL by R, that is the current, right? So you got the value of phi, you also got the value of current, right? You just got the value, guys. You have not yet plotted the graph. Now the problem is how to plot the graph, right? So guys, so when you see the value of phi, you will see that the phi is not having a time factor. So you say, oh, that means I need not draw the graph. No. See, let's say this is your axis of phi, right? And this is your time. Right? Let's make it as a little large. Okay, this is our time. So when the loop is entering gradually, right? So till the time interval, time is what? Distance by velocity. I hope you know that, right? So at time, how much is the length of the coil? Right, this much is the end, right? So this is a field, right? So the flux will change, right? First gradually. First it was, see, I'm going to replace this figure, guys. Take the rubber, rub it off. See, this was our field, right? And the coil was just entering initially. As the time goes on, the amount of the coil which is outside becomes less and amount of coil inside increases, right? That means amount of flux linkage is going to increase gradually till all the coil has entered inside the field, right? Till the coil is entirely inside the field. I hope you understood. So now at how much? when the entire length has entered with the velocity v by that time. Now the flux becomes constant because it is inside the, right, see, this was our field, and the coil now is like this. It has entered totally inside this, right, with all the length. Now when it is inside the field, or flux is constant. Why? B is constant, the area is constant, so flux is constant. So that much portion it is constant. Till how much? Till how much? Till now, once this is moving, right, this coil had been inside the field, right, so this coil is moving, still now it is moving with the velocity v. So that means after fraction of time, now it will start to move outside the field, right, and then it comes off, right. Till how much time interval it will reach outside? Till how much time interval will reach outside? Remember how much was the thickness of the field? It was d. So this coil, when it reaches outside, now the entire field is missing, right? That means now the b has changed. So how much distance has been traveled? D. So by d, this point will be d by v, right? After this d distance has been traveled by the coil, now there is a change in flux. How much? It starts to decrease, right? So this is the graph for 5. Clear? This is very easy, right? Now what is the maximum flux linked? That is this value. That is the maximum flux linked. How much is this? 5 max. Let's say Fm or 5m. What is the value of 5m will be? That means 5, I have just found the value. We've just found the equation, right? 5 is equal to bvtl. Alright, so maximum means the time interval is which one? L by v, that is the point when it is having maximum time. So replace this t with L by v, so it becomes bv into L by v into L. So you will get the equation as how much? Right, vv cancels out, there will be bl squared. So in place of Im, here I can write bl squared. That is the maximum value of flux. Clear? It's easy if you give little bit time, guys. It is not that much of complicated stuff, and I don't think today we'll be able to do the, would say, rate problem. Okay, so we'll do another question, then the time will be compensated. Okay, now the next question was what? Current graph. So again I'm going to plot like this. This is for current and this is time, right? Some of you guys can answer the answer, some of them might have found the answer now itself. Now what is happening logically? So the coil was entering into this field. So after some, right, it was gradually entering with the velocity v, right? So the same case, when L distance, the entire coil has reached inside the field, right? That means at which time period it is going to reach? L by v. Right, so initially the current is maximum. Why? While it is entering, whenever there is a change in flux, right? So now the change in flux is happening during this interval like this, right? So at that time the current is maximum. Remember? So current, when the flux is gradually changing, the current is there, right? So till L by V, the current is there. So once it reaches the field, now there is no more cutting of magnetic field lines. So now current is 0. Till when? Once it has started to pass through from the magnetic field, right? That means from where? It is from d by v, right? So from d by v, see, initially it was entering, right? Then it is leaving. So when current initially was positive, now the current will be in negative direction. I'm going to rub it off this one, right? So that we can draw the figure properly, right? So now the current is in negative direction, right? Clear? So this is our graph, and which time interval till then the current will be then? Oh, that is when time is, all the distance has been covered. Right, remember this was our field, right, inside it. inside it the coil section, right? This is our magnetic field. Then it has passed out and this much portion it has reached. That means how much the distance it has traveled, this much, d plus its entire length, right? Till then only the position we can calculate, right? Time after that is there is no relationship between the field and the coil. It was totally outside, not even the border is touching. I hope this much is clear, right? Now let's move on with another question, guys, because I don't think the rate problem can be done, right? Let's say there is a current carrying wire. Let's say this is I, right? And there is a field like this, right? And I am keeping a rod in this field. Let's say this is a rod, right? This is our A point, this is our B point. Again, my question is, what is VA minus VB? Pause the video, guys, and you guys can do it by yourself. See, what is how can I convert, or how every problem is solved? You will take, so I didn't give the direction of velocity now. This is the direction of velocity. Let's say the distance between these two wire and the rod is A. So just like any problem, you will take your palm, find the direction of V cross B, higher potential, etc, etc. I'm not going to take it again. So this point A becomes higher potential and B becomes lower potential, just like the previous cases. So the L vector from where to where? From lower potential. So this is L vector's direction, right? So I'm just going to draw the rods, okay, this is the direction of V cross B. I thought to draw another figure. It's okay. So this is the direction of V cross B. This is the direction of L vector, and the direction of B, right? So what is EMF? It is V cross B dot L, right? Vector L, right? So what is V cross B? 90 degree it goes off. So VBL, right? Just like the previous cases. Now the problem is, what is the value of B? See, this magnetic field, this is into, is due to the presence of current carrying coil, right? Or current carrying wire. So magnetic field at this point, which is at a distance A, that is our B here, right? So what is the equation for B at a distance A? Due to an infinite current carrying wire, it is mu 0 I by 2 pi r. Here it is A, right? So that means in place of B, I'm going to substitute this value. So it becomes EMF is equal to V into mu 0 I by 2 pi, okay, this doesn't come, pi A into I. Sorry guys, cannot write here, so cut it off. I'm writing here VA minus VB, or the EMF, is equal to V mu 0 I divided by 2 pi A, and there is an L. This is our answer. Clear?